This is SpaceTime Series 24, Episode 137, for broadcast on the 1st of December 2021. Coming up on SpaceTime, the Magellanic stream closer than previously thought. New Zealand's Rocket Lab launches its 22nd Electron mission. And there's been an incident involving the James Webb Space Telescope. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests the Magellanic stream is 5 times closer to the Milky Way than previously thought. The Magellanic stream's a gravitational tidal stream of high-velocity clouds of gas, dust and stars, forming an enormous arc extending from two of the Milky Way's satellite dwarf galaxies, known as the Large and Small Magellanic Clouds, over 100 degrees through the galactic south pole of the Milky Way galaxy. The stream was formed over billions of years, as the gravity of the Magellanic Clouds ripped material from each other and the Milky Way itself. In this way, the Magellanic stream tells the story of how the Milky Way and some of its closest galactic neighbours came to be, and what their future will look like. The new astronomical models reported in the astrophysical journal Letters recreated the birth of the Magellanic stream over the past 3.5 billion years. The new simulations use the latest data on the structure of the gas in the stream, and it led the authors to finding out that the stream may actually be some 5 times closer to the Earth than previously thought. Now, if correct, it means the stream could collide with the Milky Way much sooner than expected, and that would trigger a spurt of new star formation in our galaxy. The study's lead author, Scott Lucchini from the University of Wisconsin-Madison, says the fact that the model brought the stream closer to the Milky Way galaxy was surprising. And he says the new models also provide a precise prediction of where to find the stream's stars. And that's important because these stars would have been ripped from their parent galaxies together with the rest of the stream's gas and dust. But so far, only a few have been tentatively identified. Previous hypotheses have proposed that the stars are too faint to be seen because they're too far away. But with the new data suggesting that the stream is basically at the outer part of the disk of the Milky Way, it means the stars should be close enough to easily spot. The new work's based on both fresh data and different assumptions about the history of the Magellanic Clouds and stream. In 2020, the authors predicted the stream was enveloped by a large corona of warm gas. So they plugged this new corona into their computer simulations, while also accounting for a new model of the dwarf galaxies, which suggests that they have a relatively brief history of orbiting one another, a mere 3 billion years or so. Lucchini says adding the corona to the problem changed the entire orbital history of the Magellanic Clouds. In this new recreation, as the two dwarf galaxies were captured by the Milky Way, it turns out the small Magellanic Cloud was orbiting around the large Magellanic Cloud in the opposite direction of what had previously been thought. As the orbiting dwarf galaxies stripped gas from one another, they then produced the Magellanic stream. And the opposite direction orbit pushed and pulled the stream so that it arced towards the Earth rather than stretching further away towards intergalactic space. It means the stream's closest approach is now likely to be just 65,000 light-years from Earth. By comparison, the Large Magellanic Cloud is around 163,000 light-years away, and the Small Magellanic Cloud, which is slightly lower and to the west, is located around 200,000 light-years away. Put simply, the revised distance changes scientists' understanding of the Magellanic stream. It means astronomical estimates of many of the stream's properties, such as mass and density, will now need to be revised. You see, if the stream really is this close, then it's likely it has just 1/5 of the mass previously thought. And the closer approach of the stream also means its gas will start merging with the Milky Way much sooner, possibly in as little as 50 million years from now. And that will provide fresh material to jumpstart new star birth within the Milky Way galaxy, significantly altering our galaxy's appearance. This is SpaceTime. Still to come, New Zealand's Rocket Lab launches its 22nd Electron mission, And there's been an incident involving the James Webb Space Telescope. You know, it's never good when they say oops involving something worth more than $10 billion. All that and more still to come on SpaceTime. Rocket Lab has successfully launched another 2 satellites into orbit aboard its Electron rocket. The mission was the 22nd from the company's Mahia Peninsula Launch Complex on New Zealand's North Island east coast. The Love at First Insight mission successfully placed 2 Black Sky Gen 2 Earth imaging satellites into a 430-kilometre high orbit.
Vehicle is on internal power. AFDS is green and enabled for flight.
Copy avionics.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed.
High flow engine purge is enabled. Deluge activated.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Confirm liftoff.
Stage 1 propulsion is nominal.
T plus 46 seconds, and there goes another Electron on its way to space for this 22nd launch from the pad from Rocket Lab Launch Complex 1. Soon the rocket will experience its peak amount of stress as it travels incredibly quickly over a large distance. This moment is called maximum aerodynamic pressure, or what's known as max Q, and is one of the first gates Electron needs to clear to make it to orbit.
Past max Q.
And we have passed max Q, and Electron is continuing the journey to space. Propulsion looks nominal on Electron's first stage as the rocket approaches the next major milestones of launch. In a few moments, Electron's 9 Rutherford engines will throttle down and then shut off completely to slow the rocket down. This milestone is called main engine cutoff, or MECO, and it occurs just before Electron's first and second stages separate. Once that's happened, very quickly, Electron's 10th engine on the second stage will light up to maintain its trajectory and continue carrying the 2 satellites to orbit. After these launch events are cleared, it's then that our rocket recovery operations begin, with the boosters' descent back to Earth. But first, let's wait to hear the call out from Mission Control that those events have occurred successfully.
MECO confirmed.
Stage separation successful.
Stage to ignition.
There you have it. Electron has had a successful MECO, stage separation, and second stage engine start. Stage 1 recovery operations will now proceed with the vehicle's successful stage separation.
Bearing separation confirmed.
Electron's fairing has successfully separated as we get ready to deploy the 2 Black Sky satellites to their low Earth orbit within the hour. In about 1 minute or so, Electron's first stage will reach apogee. Now, when the first and second stages separated, Electron's booster is still travelling at such a speed that it continues moving upward before gravity begins to take over. So once Electron's first stage reaches apogee, or its highest point, the only place for it to go next is back down. We should hear that call soon from Mission Control. Okay, we are just past T plus 4 minutes into flight, and Electron Stage 2 is travelling nominally at a speed of over 8,000 kilometres an hour and an altitude of over 167 kilometres. In less than a minute, Electron's first stage should reach apogee with orientation of the stage underway as planned.
Stage 2 propulsion is nominal.
Stage 1 apogee.
And with apogee confirmed, Electron's first stage is officially on its earthward trajectory. The next milestone in our recovery operations will be the deployment of the first chute on Electron's booster. Meanwhile, Electron's second stage engine is burning bright and beautiful on the way to orbit. The vehicle is currently at speeds of more than 10,000 kilometres per hour and an altitude of more than 200 kilometres. We have got some good telemetry coming in for how Electron is travelling to low Earth orbit, with the second stage travelling at more than 11,000 kilometres per hour, more than 214 kilometres above Earth. Electron's booster is now on the correct angle of attack to re-enter the atmosphere from space, where it separated with the second stage as per normal launch procedure a few moments ago. All systems are continuing to perform well across both stages of the vehicle. Our next launch event will be the battery hot swap set to take place on Electron's second stage. Because our Rutherford engines maintain their power source from batteries, at a certain point those batteries run out of charge. So we need a fresh new one to keep the engine running. And what we do is we swap the power from the depleted batteries to a third fully charged one, all while keeping the second stage moving at more than 13,000 kilometers an hour. We'll hear that moment called out through mission control shortly before we expect to hear the next recovery operation milestone, that deployment of the drogue parachute. Let's listen in.
Hot swap successful.
Battery jettison confirmed.
And stage 2 propulsion is holding nominal.
And there we go. That we had the good news of battery hot swap there on Electron's second stage. Next up in recovery operations will be the main parachute release. We should be hearing that call shortly.
AFDS has safed. HVB discharge holding nominal.
Stage 1 main chute deploy.
The parachute on Electron's booster has successfully deployed, and so our recovery helicopter is in the air on its way to get a glimpse of the booster coming back to Earth. All going well, the first stage should now glide gently toward the ocean, remaining in the air for another 10 minutes or so from the parachute's release. Right now, though, high above Stage 1 recovery, Electron's primary mission is continuing nominally, with the second stage powering its way to low Earth orbit. In under 2 minutes, this stage will be approaching its next event, second engine cutoff, or SECO, and then separation from its orbital transfer vehicle, the kick stage, which will carry the 2 black sky satellites to their destination. We won't have an immediate engine burn on the kick stage following that separation, as it goes into a coast phase while it's in an elliptical orbit before its Kourou engine ignites and jolts it into a circular path for payload deployment. We'll wait to hear that stage separation call come from mission control shortly.
Guidance is in terminal, 25 seconds remaining.
And SECO confirmed.
Stage 3 separation confirmed. Nominal transport orbit received.
There you go, another smooth achievement of our latest mission milestone. The Rutherford engine on Electron's second stage has shut down as planned, and the kick stage has now separated on its way to payload deployment in about 45 minutes or so.
The spacecraft add to Black Sky's growing constellation of real-time geospatial monitoring satellites. 5 Black Sky satellites have now been deployed into orbit over the past 3 years. Rocket Lab also used the launch as another dress rehearsal for their future plans to undertake core stage rocket recovery. A helicopter was used to track and monitor the descending Electron rocket's first stage during its re-entry. It's all part of a program to eventually undertake the aerial capture of the Electron rocket during its parachute descent in order to refurbish and reuse the launch vehicles. The helicopter was stationed in a recovery zone 200 nautical miles offshore. It tracked the returning rocket and undertook communications and telemetry tests in the recovery zone. Another 2 Black Sky satellites are slated to launch later this month on Electron's next mission, a Data with Destiny. And that flight will attempt an aerial recapture of the Electron rocket core stage by helicopter during its parachute descent. This is SpaceTime. Still to come, there's been an incident involving the James Webb Space Telescope, and NASA continues work to restore the Hubble Space Telescope. All that and more still to come on SpaceTime. Well, the term oops is something you never want to hear when moving a $10 billion space telescope. But that's just what's happened at the European Space Agency's Kourou spaceport in French Guyana, as technicians were attempting to attach the new James Webb Space Telescope to its launch vehicle adapter on the upper stage of an Ariane 5 rocket. The incident involved the sudden unplanned release of a clamp which was securing the James Webb to the launch vehicle adapter. The event sent a vibration shuddering through the massive telescope. A NASA-led team's now investigating how the incident happened, and they're carrying out tests to determine if any of the delicate components in the telescope have been damaged. The James Webb Space Telescope was to be launched on December the 18th. That's now been delayed until at least December 22nd, depending on what mission managers find. James Webb is the largest and most powerful space telescope ever built. It's designed to take over where Hubble finishes off, looking back in time more than 13.5 billion years to see the very first stars and galaxies that formed just a few 100 million years after the Big Bang. This is SpaceTime. Still to come, NASA continues work to restore the Hubble Space Telescope following a recent safety shutdown, and another week means the launch of another Chinese spy satellite. All that and more still to come on SpaceTime. NASA's continuing efforts to bring the Hubble Space Telescope back online after it suddenly went into safe mode in October. Mission managers are still trying to understand what caused the orbiting observatory's loss of synchronization issues which triggered the safety shutdown. Technicians have now brought the Wide-Field Camera 3 instrument back online, which undertakes about a third of the telescope's total observing time. It follows the successful reactivation of the Advanced Camera for Surveys instrument back in mid-November. Engineers have also begun preparing changes to the instrument's parameters, allowing it to handle several missed synchronization messages while continuing to operate normally. These changes will first be applied to another instrument, the Cosmic Origin Spectrograph, to further protect its sensitive far ultraviolet detector. NASA says it'll take their team several weeks to complete the testing and upload the changes to the spacecraft. This is SpaceTime. Still to come. Another Chinese satellite reaches orbit, bringing Beijing's total spy satellite surveillance network to 148 spacecraft. And later in the science report, a new study warns that deforestation of the Amazon rainforest has increased by a devastating 22%. All that and more still to come on SpaceTime. Another week means the launch of another Chinese Earth reconnaissance satellite, bringing Beijing's total to over 148 surveillance spacecraft as the communist superpower continues what it describes as preparations for war. The Gaofang 1103 was launched aboard a Long March 4B rocket from the Taiyuan Satellite Launch Center in China's northern Jiangxi province. The spacecraft's been placed into a 450 by 690 kilometer high sun-synchronous orbit. Beijing says the satellite will be used for land surveys, city planning, land rights confirmation, road network design, crop yield estimation, and disaster prevention and mitigation. However, the optical high-resolution spacecraft's primary role will be monitoring the military operations of other countries of interest to Beijing. The Gaofang 1103 is China's 44th orbital satellite launch so far this year, and the 397th flight of the Long March series rocket. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Deforestation of the Amazon rainforest has increased by a devastating 22% over the past year, according to new figures from the Brazilian government. The data by Brazil's National Space Research Institute shows that 13,235 square kilometres of rainforest was cut down between August 2020 and July 2021. That's the highest amount of loss since 2006, when some 14,286 square kilometres were lost due to logging. It's the third year in a row that annual Amazon deforestation has increased under the current government. A new study has found that some Pacific Ocean rockfishes can live for more than 200 years. The findings, reported in the journal Nature, suggest that their secret to longevity is growing large, very slowly in deep frigid waters. Scientists found that the longest-lived fishes have genes that affect lifespan by influencing size and adaptability. Their genetic makeup also includes more copies of genes linked to DNA maintenance and resisting the inflammation that often comes with age. Oh, shock horror, a new study has found that people who consume coffee were on average more active than those who didn't. But the study also found that drinking lots of coffee means you sleep less and suffer from an increased number of abnormal heartbeats. The findings by scientists at the University of California, San Francisco, and reported to the scientific sessions of the American Heart Association are based on randomized trials of 100 adult volunteers with an average age of 38. Coffee is the most commonly consumed beverage in the world, but its health benefits remain uncertain. Different studies are giving different results. In this latest study, scientists found that coffee consumption was associated with a 54% increase in premature ventricular contractions, a type of abnormal heartbeat originating in the lower heart chambers, reported to feel like a skipped heartbeat. But the authors also found that drinking more coffee was associated with fewer episodes of abnormally rapid heart rhythm arising from the upper heart chambers. A new survey has found that despite all the warnings, 1, 2, 3, 4, 5, 6 and the word password are still the most popular passwords in Australia. With the details, we're joined by technology editor Alex Zaharov-Reutt from ity.com.
Yes, NordPass has released global research on these passwords, and the most popular password in Australia is 1, 2, 3, 4, 5, 6. The number 2 is the word password itself, and there's also words like QWERTY or QWERTY 1, 2, 3. Even things like I love you, monkey, and dragon are in the list. These can be cracked in seconds if someone's trying to target you and they're using some sort of program to do that. And in Australia, we also see Australian men, according to the report, using Holden.
That's sort of the Australian version of Chevy in the States, by the way.
Yeah, that's right, yeah. And the 8th most used by Australian women being chocolate. And also they say that women like to use the name of artists like One Direction is one word, or Justin Bieber is one word. And men use the name of sports teams like Steelers in the US and Liverpool in the UK. So people definitely need to get creative with their passwords. They should use a password manager, which can automatically generate a complex password for you. Remember all the passwords for probably the 100 different services that a lot of people use these days. With a password manager, you just have to remember one password, which is the password for the password manager itself, and it stores all the rest. And then, of course, if you've got multi-factor authentication, where you can use SMS or better still some sort of app, then if someone does find out your username and password, they will not be able to log in unless they also have the ability to receive your SMSs, which some hackers figure out how to do, but that's why you also use programs like Google Authenticator and others to create codes. And you really have to do that in the 21st century.
That's Alex Zaharov-Reutt from ity.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.